Hi, I'm Sean Higgins, editor for spar3d.com and the Spar3D newsletter here at ILMF 2019 in the nFrames booth with Conrad. Your software is photogrammetry software. I mean, for the layperson, how much has photogrammetry changed in 5 years? And what sort of new things does your software package bring to the table?
So actually the last 5 years are really tremendous in many changes. So we are a very focused company, like we are particularly focused on photogrammetry for very large scenes. And we have been seeing like two things. So the one thing is particularly coming from the industry. So the sensors has been a vast increase in productivity. So just the cameras, like 5 years ago we were still had airborne cameras with like 200, 300 megapixels. Today they do like 400, 500 each, right? So we have people that capture like 800 megapixels every half a second, right? So this is a tremendous amount of data that people have to process. And I mean, so there comes a lot of questions and like, how can we really do this? How can we scale this? How can we manage this, right? So these people really are suffering from terabytes of data that they capture actually on a daily basis, so to say. And on the other hand, we see a lot of like, it's not image only, right? So we started as a company doing dense image matching, like getting DSMs, true orthophotos, meshes, point clouds from images. And over particularly the last 2 years, it has changed a lot towards, hey, can we incorporate also other sources like LiDAR data as well? And we learned so much about how we can also improve results and like compensate downsides that maybe one sensor has with the other one. And it's tremendous to see like how fast this is all evolving now with combined sensors and things like this.
So, I mean, to put you on the spot, which of these two things do you think is a bigger challenge to meet as a software developer? The sensor fusion issue or the issue of scaling to account for the tremendous amounts of data that people are capturing?
That's a very good question. At this point, I think it is still both. So on the one hand, we spend like probably 70–80% of time in engineering. So bringing up, on the one hand, that you have on one computer, you can process really big data sets, even on 32 gigabytes of RAM on an Amazon instance or on an own computer. So you can scale up and feed it with like 20, 30,000 images, and it should run for weeks or for a few days if you scale it to many computers, right? So this is then the distribution on many nodes. So we have a lot of engineers that just do this like all day long, and they try to subdivide the data chunks in smart ways and then fuse it again so that it stays consistent. So we spend a lot of time in that. On the other side, asking about the data fusion, we are learning a lot recently also from research on error models. So how does this sensor behave? So we cannot treat every point as the same thing, right? Instead, we really have to know how accurate is this one. So in LiDAR, you can very often see it very easily, so to say, because the sensor has a certain noise. But in oblique imagery, the points in front have a much better resolution and accuracy than the points far away. Plus, you are also depending on the image configuration. So what we have to do now is to understand very well for every point how good it is, and then decide locally what is the better point to take, or maybe we can even fuse it. So in images, you, for example, are very poor in shadows, right? But you are very good on details and edges. And on LiDAR, you are much better in shadows because it's an active system, right? And with little concavities because you only need one shot. But it's not as like sharp on the edge side and the amount of detail. So now we have to do these local decisions, and it's a very exciting time on how to do this right now.
So I suppose this would be, of course, the perfect time for you to talk about how your software approaches some of these problems, the problems of scaling or the problems of fusion, and what exactly a person using your software, say, for I don't know how many hundreds of terabytes of data, including LiDAR and imagery, like what can they expect to be able to do with your software?
So on the one hand, in the very traditional photogrammetry market, you can go from error triangulation and fully automatically gate for entire cities, and many of our clients, even entire countries as well. They get DSMs, true orthophotos in a fully automatic way in 2.5D fashion, and also like 3D meshes on the one hand. So people either use this on workstations, on servers, on-premise clouds, or like in the full cloud. On the other end, we now can also incorporate LiDAR additionally. So if, for example, can close up gaps in your DSM, and you can just have both together at the same time, right? And what we're recently just publishing right now is also you can now do actually a 3D mesh also from LiDAR data only, but like on a very scalable way. So for example, we have just meshed the data set from San Francisco for the entire area in like just 3 hours. You can get the entire geometry, so it's really, really fast. Then you put the texture in it and you get like photorealistic models, so to say, right out of the LiDAR data. And the whole perspective comes, of course, in on how can you iteratively improve this and like really get to this optimal product for your particular workflow and balance flying time on the one end, which is a major limitation of this industry, right? As well as processing time, which is this time to delivery and hardware, right? And this is a constant like game that we also have to discuss with clients also like on this show here.